3.7 is all about optimization. So what does it mean to be optimal? Ultimately, it means that you're always looking for the best solution to a single problem. You're always trying to find either the minimum or the maximum. And one easy way for you to set up an equation from a word problem would be to use two equations, including the primary, which has the quantity that needs to be optimized, and secondary, which helps you put the pieces together. So an easy way to look at optimization would be to follow these 7 steps. First, you must find two equations like we talked about earlier, the primary and the secondary. Second, solve for the secondary. Usually that includes the y. Third, you plug in your y to your primary equation. Fourth, you take the derivative, you set it equal to 0, solve for x. And step 7, you plug in x to find the y in the equation. That will only allow you to get one variable. Okay, so let's take a specific problem. Sammy is making fruit punch from a frozen can that holds 32 inches cubed of material. So we want to find the minimum surface area of the can. So we could use optimization for this problem. So let's begin with the equation v equals pi r squared h and make that equal to 32 inches cubed, which was the amount given that the can can hold. So we can identify this because there's a given value in this, and we look at step 2 and we see that there's usually a y or a value that's included. We can say that this is the secondary equation. Our next step is to use the equation of the area of a cylinder, and sometimes it helps to draw. So here's my can, or I could lay it out flat and have this side 2 pi r, this side h, and have this here as r, and this as the height. Now after we have the equation of our area, we can solve for the h, and we find that h equals 32 over pi r squared, and we plug that value into h. Now, we can cross off and simplify. So this is the same as saying 2 pi r over 1. We could cross off the pi and the r, and that would give us a equals 2 pi r squared plus, you multiply the 32 and the 2, and these cross off, so there's an r left in your denominator, and you have 64 over r. And now we set it equal to 0. Or I'm sorry, we take the derivative first. So the derivative of a equals 2 pi r squared plus 64 over r is dA over dr. And we keep it dr because it's in terms of radius. And that becomes 4 pi r minus 64 over r squared. And we get that because we bring the exponent out in front, and we do the low d high, high d low with your 64 over r, and then you set that equal to 0. Now your next step would be to solve for r. Cross multiply here. Divide by 4 on both sides, and you get 16 over pi And now you take the cube root of both sides, and your final answer is, oops, you probably want to keep it lowercase because that's the variable you've been using all along. So r equals the cube root of 16 over pi. And that is how you do optimization.